main focus for us this year is demonstration of capabilities of our new product, V2S voice vibration sensor. So you can see a photograph of the product over here. It sort of looks like a conventional MEMS microphone, and the Knowles is well known for experience in the industry with MEMS microphones. However, this sensor is instead of being sensitive to acoustic pressure, it is picking up vibration. You can think about it as a one-axis accelerometer with very wide bandwidth, high SNR, small package size, and small power consumption. So today we're showcasing several applications where wide bandwidth accelerometer can be used to bring value for devices with audio in them. So this is a demonstration of a Knowles vibration sensor called V2S for a medical application. Here I have a prototype of a stethoscope. So think about the conventional, most commonly used stethoscope that is common in medical industry. So it's a rubber hose, no electronics device, and its design hasn't changed over the last 200 years. There is certainly a trend now to get more telemedicine and use more electronic devices. So electronic stethoscope allows recording data, plotting it, listening to it later, using remote diagnostics. So benefits are obvious there. Commonly for electronic stethoscopes, people use microphones and some advanced integration to harvest good heart signals. Today we're showing how simple it can be implemented using vibration sensors. So in my hand, I simply have a prototype with a plastic diaphragm and just a sensor on flex attached to it with double sticky tape. Nothing else, no machined parts, no complicated housing, very straightforward. And what you see here is 5 seconds worth of data that we recorded. And you see on the raw data on the left, individual heartbeats that we acquired. Heartbeats are very rich in the low frequency signal, and actually in order to clean them up, we can get rid of high frequency data and apply some noise suppression to further clean up the signal. And you can see main pulses, but also the structure at the lower level, so to speak. The heart is a complicated muscle. It opens and closes the valves. There are different compartments of the heart. And so the internal structure of that sound carries a lot of information for medical diagnosis. So in order to demonstrate it, I'm going to go into the live function. So just putting it against my chest. So you can see individual pulses coming from my heart. This demo is talking about capturing sound with Knowles V2S vibration sensor using so-called sound-induced vibration mechanism, where a sound wave propagating through the air is impacting the surface, and the surface starts vibrating, and the vibration sensor is taking that signal as input. The benefit here is ultimate environmental robustness. There's no porthole needed to be open to the outside world, so automatically it gets ultimate protection from the elements. So let's do a recording. In here I have a vibration sensor placed on a side view mirror of the car. I will start recording and say a few commands. Hello, 1, 2, 3, 4, 5, 6, 7. Car, open the door. This is the data that we just collected. You can see that speech spikes in the signal are clearly visible. And in the frequency domain, you can see it's a broadband signal up to 10 kilohertz, no problem. So let me play back for you raw data. Hello, 1, 2, 3, 4, 5, 6, 7. You can clearly understand the speech. It's actually a decent quality signal. and for a voice command application or for siren detection, it will be quite useful. A couple of simple steps for signal post-processing can further clean up the signal and make it more comfortable for listening. Here, I apply equalization and some basic noise suppression.
Hello, 1, 2, 3, 4, 5, 6, 7.
So even further more comfortable for listening with just single vibration sensor and maximum environmental robustness built in. So this in order to conclude the demo, I want to show you a final solution, which is demonstrated here as a result of work of Knowles with a few partners. So this is a full system on a toy car where vibration sensor is placed under the windshield of this car, and voice recognition and the keyword detection algorithm is running on the evaluation board to execute the command. Hello, my vehicle. Close the door. So this just shows full system from signal detection and post-processing, and amount of signal captured when the sound hits the windshield. Windshield vibrates. Vibration sensor picks up that vibration, and the post-processing is done. All that signal is sufficient to detect and execute the command. Thank you. That concludes the demo.